More oceans across the solar system. The Event Horizon Telescope zooms in on an active galactic nucleus, and another lunar lander sets off to the moon. All this and more in this week's Space Bites. That's no moon. Actually, it is. That's Mimas, which is one of Saturn's moons. And it's really cool because it has this gigantic crater on the surface that was caused by a giant impact in the past. And this crater actually takes up about a third of the size of Mimas. And so it's often used as a, I don't know, some kind of natural version of the Death Star. But Mimas is very interesting. It's one of Saturn's icy moons. And, you know, we've talked a lot about the discoveries of oceans under thick shells of ice on various objects across the solar system. We know they're at Europa and Enceladus and Ganymede and Callisto and maybe Pluto and all these various places across the solar system. But it was assumed that there was like this minimum size that you would have to get where you need a fairly large moon or dwarf planet before you could get this thick icy crust and then a liquid ocean underneath that and then some kind of geothermal activity that's maybe putting nutrients into the water and maybe there's life down there. And now astronomers have found evidence that there's a liquid ocean at Mimas. And Mimas is very small, like it's only about 400 kilometers across, much smaller than the other large objects that I mentioned. And for the longest time, astronomers thought, no, there's nothing on Mimas. It's cool, it's dead, don't think about it. And they thought that because the surface of Mimas is just so heavily cratered. And so you don't see evidence of resurfacing. Astronomers looked at old images taken by NASA's Cassini spacecraft, which is no longer with us, but has plenty of pictures of the solar system. And they were able to just measure the amount of craters on the surface. And what they found was, in fact, no, Mimas has been resurfaced. The surface of this world is probably only about 15 million years old. And it's been around for a lot longer than that. And so it's undergone some kind of resurfacing event in its recent history. And so that means that it probably still has some level of active geothermal activity underneath the surface. It probably has some layer of liquid water underneath the surface. And so now, if objects like Mimas have a liquid ocean, like everything's up for grabs here in the solar system. Now, I want to talk about this some more at the end of this episode, so stay tuned for that. Speaking of geothermal activity, Eris and Makemake. So we talked about one of the icy moons of Saturn, and we know that there's ongoing geothermal activity at Pluto. You can see the resurfacing events going on that world. Well, two other dwarf planets seem to also have geothermal activity, and that's Eris and Makemake. Astronomers used James Webb to analyze the surface of these two dwarf planets. And what they were looking for was the presence of methane. They found it, and so then what they were looking to do is try to figure out whether this methane is young or old. Old methane contains deuterium, also known as heavy hydrogen, and it was formed at a very specific ratio after the Big Bang, while newer methane was formed inside Eris or Makemake through geothermal processes. And so when James Webb looked at Eris and Makemake, not only were they able to see that it does have methane on the surface of the world, which is already kind of interesting, it was able to know whether this methane is relatively new or as old as the universe itself. And this is just mind-blowing that this incredible telescope not only is able to look back to almost the beginning of the universe, but it's able to see these objects inside the solar system. Now, I've got an interview coming up next week with one of the researchers behind this discovery, so stay tuned for that. And there's even more water in space. Now astronomers have found evidence that there's water on the surface of asteroids. And so to set this up, think about that discovery of water in the regolith of the moon. This was announced a couple of years ago, and the discovery was made using NASA's Stratospheric Observatory for Infrared Astronomy, or SOFIA. This telescope was an infrared observatory that was mounted inside a 747 aircraft, and then it would fly above most of the atmosphere that would prevent the wavelengths of infrared from reaching the surface of the Earth. And so it was able to be kind of like a space telescope that could take off from an airport. They discovered the presence of water mixed in with the regolith on the moon. And then they asked themselves, okay, if we can find it on the moon, could we find the same stuff in asteroids? And so they analyzed 4 different asteroids, and they were able to find a strong signal for water in the regolith of these asteroids. The 2 asteroids are Massalia and Eris, and then they had 2 other asteroids where they weren't able to detect the same strong signal. So the question is, where does this stuff come from? Now, with the regolith on the moon, it appears that the solar wind particles are interacting with the regolith. Protons, hydrogen, are impacting the surface of the moon. They're mixing with oxygen on the surface of the moon, and they're forming water just right in place. And so this same process must be happening on the surfaces of asteroids. It's not a lot of water. I mean, it's like 1 water bottle mixed in with 1 cubic meter of regolith, but still, when we go to asteroids, if we need water, we might be able to just extract it right from the surface of the asteroids. Another lunar lander is off to the moon. Another week, another mission to the moon, and this time it is Intuitive Machines Odysseus lander. The mission took off Wednesday night on a Falcon 9 rocket and is now going to make the 8-day journey to get to the moon. The landing is set for February 22nd, so just less than a week when you watch this video. The primary payload on board the lander is coming from NASA, and it's got a series of experiments that they want to test out on the surface of the moon. They've got an instrument that's going to measure the dust plume, so when this lander sets down on the moon, how much regolith dust is kicked up. And this could help understand, when many missions are going to the moon, how much dust will they kick up? What kind of risk does this pose to future missions going to the moon? It's also going to have a radio navigation beacon. There's like a bunch of other experiments that NASA is planning to do this. And this is part of a new philosophy with NASA, that instead of building their own spacecraft to go to the moon, they're paying for a rideshare where they pay for a ticket to the moon to deliver their experiments to the surface of the moon. If they're able to pull that off, then we could see this future where there's a lot more commercial activity going to and from the moon. In addition to the NASA payloads, there are also some private payloads. One is a selfie camera that's going to take a picture of the lander itself. And one, and I'm really excited about this, is it is a mini observatory. It's like a mini space telescope sitting on the surface of the moon that's going to take the first ever image of the Milky Way from the surface of the moon. So right now, when you're seeing this, we don't know how this mission is going to do. Will it succeed? I'll let you know next week. More spacesuit tests. Last week, we talked about how NASA is testing out prototypes of their lunar spacesuits, but they've actually ordered new versions of their extravehicular spacesuits. These are the spacesuits that the astronauts wear on the International Space Station when they do spacewalks, where they go outside the station, repair various instruments, install new experiments, things like that. NASA wants new EVA suits. And you can imagine, like, not just for the International Space Station, but for other missions that they're going to do. Think about the Deep Space Gateway. They want a new class of spacesuits that work in a weightless environment. NASA has ordered a new set of spacesuits from a company called Collins Aerospace, and this week they showed us how they're testing one of these prototypes. They put it on a zero-G aircraft, also known as a vomit comet. These are these aircraft that do parabolic flights, so they fly up, give you 20 seconds of weightlessness, and then they fly down, and then you get 20 seconds of double gravity, and then they do the same thing over and over and over again. And this inevitably leads to people vomiting, I guess inside their spacesuit. Yuck. Anyway, so the goal was to test the mobility and safety of this spacesuit in a weightless environment. And so for the 20 seconds of weightlessness, they had the astronaut test if they could move through tight confines, how it worked in this weightless environment. And then from that, they're going to be able to move on to their next test. And the next test is to test in the neutral buoyancy lab. These are these gigantic pools where they have mock-ups of the International Space Station. So the astronauts will be in this water tank, testing out different tools, instruments, how well it works, moving around the outside of the space station. And then from there, we'll see other testing, probably more vacuum testing, and then eventually one of these will fly to the International Space Station. Every week, we do a vote on our channel where you tell us what you thought was the most interesting story of the week. And last week's winning vote was James Webb finds another impossible galaxy. So thank you everybody who voted. If you wonder how this works, within 24 hours of when we do Space Bites, we put up the poll in the community tab on the YouTube channel. And so you can go to the community tab and see that, but like who does that? You're probably just scrolling YouTube and you're going to see the poll show up. So pick the one that you like the best and then we'll count up all the votes and we'll celebrate it here. And so the best chance to be able to find out about these polls is be subscribed to the channel. Why aren't you subscribed to the channel? Subscribe. It's free. It's easy. Confirmation of double rogue planets. A few months ago, we talked about the discovery of JUMBOs, Jupiter mass binary objects found in the Orion Nebula. They found hundreds and hundreds of these Jupiter mass objects, as well as objects all the way down to about Saturn mass objects. What was really interesting about this discovery was that several of these objects were in binary pairs. And so you had two of these Jupiter mass objects orbiting one another. How do you get that? Like, one possibility is that these objects are kicked out of other star systems and they somehow found their way to each other, went through some kind of three-body interaction, were able to go into orbit with each other. That's pretty remote. The other possibility is that these things formed in place, that you didn't have enough material for a star or a brown dwarf, but you did have enough material for a Jupiter's worth of star. And so you got just a rogue planet, and maybe you could get two of them forming in place like a binary star system does. With any kind of scientific discovery, the next step is to try to confirm it. And so astronomers used radio telescopes to find out if they could detect these objects in the radio spectrum. And we got a paper this week that said that yes, indeed, they were able to detect one of these objects, Jumbo 24. They were able to detect the wavelengths of radio emissions coming from this object that's very similar to an ultra cool brown dwarf. In other words, the smallest possible brown dwarfs that are out there, that they have detected radio emissions coming from them. And the radio emissions are kind of similar to the auroras that come off of Jupiter. And so what you're probably seeing are the auroras on these Jupiter mass binary objects. And so it's great confirmation. See them in James Webb in the infrared, confirm them in a radio telescope. These things are real and weird. Now, I've got an interview coming up with one of the researchers who discovered these objects in the first place, so stay tuned for that. The Deep Space Network's new hybrid antenna. So take a look at this picture. This is the Deep Space Network's DSN-13 radio telescope. And if you look at it carefully, there's one additional box at the middle of the antenna. And this is an optical terminal that has been retrofitted onto this radio dish. A couple of months ago, I talked about how NASA has been using lasers to communicate information in space, and they were able to receive an enormous amount of data from the Psyche mission, specifically a cat video. And so with DSN-13, they retrofitted it with this optical terminal, and then they directed it at Psyche to receive data. But they were able to receive both radio data coming from the spacecraft as well as the optical laser data at the same time. And they found that with this hybrid approach, they got 40 times more bandwidth coming from the spacecraft. This is really important because NASA's Deep Space Network is oversubscribed. There are too many spacecraft, not enough radio dishes, and to be able to get all of the data back home, especially for the ones that are really far away. When you think about communicating with the Voyagers, which are really far away, you have to have a very big dish that can get any kind of data coming from the spacecraft. And so if we can start to shift over to get more and more coming from lasers, then maybe this provides a lot more capacity for spacecraft to be able to send a lot of data back home. So this is a really exciting development. I mentioned this at the end of the year, last year. I think this is one of the most exciting developments in space exploration. Faster communication, more bandwidth. I know it seems kind of mundane, and yet this could unlock entirely new missions. In addition to all of the videos that we do, the podcasts, I also write a gigantic email newsletter every week that goes out on Fridays. And so if you want to be able to get all of the stories that I'm thinking about. And not just the stories we're covering on Universe today, but really all of the interesting stories that I saw just across the entire internet. You should definitely subscribe to my weekly email newsletter. It goes out to 70,000 people. It's totally free. I write every word and you can subscribe. Go to universetoday.com/newsletter to sign up. The Event Horizon Telescope zooms into a black hole's jets. We've talked quite a bit about the Event Horizon Telescope and how we've seen images of the event horizons around the black hole at the heart of M87 and the black hole at the heart of the Milky Way. And that's because these are visually the two largest event horizons that we can see from Earth. But the Event Horizon Telescope can be used to look at other things as well. And so this week, researchers released new pictures where they took the Event Horizon Telescope and they looked at the heart of a supermassive black hole that is actively feeding, also known as an active galactic nucleus. Like one version of this are quasars, when you've got a supermassive black hole that is actively feeding on dust and gas and material, and the jets that are coming out of this black hole are directed towards us. We see this incredibly bright object. And so the Event Horizon Telescope wanted to look at the vicinity around one of these actively feeding supermassive black holes. The target that astronomers chose is called 3C84, also known as Perseus A. And this is a supermassive black hole that's about 230 million light years away, which is very far away. And so this image that you're looking at, they zoomed in using different telescopes. So over on the left, you've got the Very Large Baseline Array at a wider field of view. And so that little line down there that you can see, that's 2.3 light years. So you're seeing a region that's about 2.3 light years across. And then they zoomed in at a different wavelength. You can see also 2.3 light years. And then they switched to a different instrument. And in this, you can see they're only looking at 0.3 light years. And the final image is using the Event Horizon Telescope. And so that scale down at the bottom shows 0.06 light years or 250 solar radiuses. And just to sort of give you some perspective, that's about 1 astronomical unit. So you're looking at a region that is about the distance from the sun to the Earth. In that final image, you're seeing distinct blobs of material that are being fired away from this supermassive black hole, forming this jet that can be seen in a much wider field of view in other telescopes. So astronomers are trying to understand, how does the black hole interact with its environment? How do the magnetic fields that twist up around the accretion disk of the black hole help channel these jets that come out of the black hole? And the Event Horizon Telescope is just the right tool to do this kind of job. What happened after DART? About a year ago, NASA avenged the dinosaurs when they crashed a spacecraft into an asteroid. And this was the Double Asteroid Redirection Test. And the plan was they're going to crash a spacecraft into asteroid Dimorphos, which is a moon of asteroid Didymus, and measure how they change the orbit of this moon going around this larger asteroid. And the test was successful. They did change the orbit pretty significantly, and the impact caused this trail of debris to come off of the asteroid. Telescopes around the world were watching as this debris tail formed. It was kind of like a comet tail that was then pushed by the solar wind away from the asteroid. The small particles were pushed away into space. Other smaller objects were also pushed away. But one question that astronomers had was, what happened to the bigger boulders? Because objects as big as about a meter across were dislodged from Dimorphos during this impact. And what they found after they did their simulations was that these boulders were likely recaptured by Didymus and Dimorphos. They crashed back into the asteroids after being kicked out. So all of the debris is kind of kept in the system, and people were worried, like, is this stuff going to be a hazard for the future of the solar system? And the answer is no. Although, like 1 meter asteroids aren't really a hazard anyway. But still, it looks like all those boulders sort of came back into the system after the impact. I'm going to talk about ocean worlds in a second, but first I'd like to thank our patrons. Thanks to Stephen Filler Munley, Paul Rohrbach, Abe Kingston, Hey Twyla, Dougie Stewart, Stephen Krasaki, David Richards, Mark Ansis, Joel Yancey, Antonio Filara, Dustin Cable, Vlad Chiplid, Modso George, David Giltonan, Andrew M. Gross, Jeremy Mattern, Josh Schultz, and Jordan Young, who support us at the Master of the Universe level, and all of our other supporters on Patreon. Not gonna lie, this story about Mimas and the discovery of geothermal activity on Eris and Makemake are blowing my mind. At this point, we're confident there are oceans of liquid water underneath the surface on Europa and Enceladus and Callisto and Ganymede and Titan. But these are giant worlds. Like, we only have so many of these big objects here in the solar system. But the fact that they're finding it on Mimas and other small moons at Saturn and Jupiter, that it appears that there is geothermal activity on Pluto, and now on Eris and Makemake, which are other dwarf planets that are farther away from the sun. Are they on Sedna? Are they on, like, how small will you still have a geothermal activity and a subsurface liquid ocean? And at the same time, I'm kind of sad because we know that there isn't a lot of material that is available to organisms that could be under the ice. There just isn't a lot of free energy that organisms could use. And so even if we do find the presence of life, say if Europa Clipper passes through a plume in Europa and finds evidence of life, there probably won't be a lot of activity. And then we probably won't see those giant European space whales. We're going to find microbes that are huddled around deep sea vents struggling for survival. And yet, is that the majority of life in the universe? Are most of the worlds out there that have life on these ocean worlds, and how will we ever be able to find out about them? It's hard enough to find the presence of life here in the solar system. How could we find them around rogue planets drifting through the Milky Way, or on exoplanets that are orbiting gas giants, orbiting other stars? And so, like, I'm excited, and yet I know that for us to be able to find any kind of conclusive proof about them is going to be tricky. And then you wonder, like, if you are some intelligent octopus or European space whale that evolves on some other world, can you form, is there any technology available to you? Could you ever find out that you live in a vaster cosmos? Anyway, these are the kinds of things that fuel my imagination. We'll see you next week.